Hey everyone, welcome to this second module. This week we'll be taking a look at software engineering, digital systems, and electronic test. So let me just pull up the Canvas page here. So here I am on the Canvas page. It looks a lot like the first module. We've got a section for the report, a quiz, and extra credit. And once I publish this, we'll have the video linked up as well. So in the report section, you'll find the PDF for the book. You'll want to re-download it if the download that you did last week only had the first chapter, because this new download has chapter 2 in it. So let me just pull that up. So here's chapter 2. So the first thing we're going to be taking a look at is programming languages, in particular the C programming language. So you might have heard of the C language before, but here is a good reference guide, and we'll just be exploring some of these core C language constructs and learning about the C language, just because the Arduino language is built on top of C. So it would be good to have this background before we dig too far into Arduino. The next thing that we'll be taking a look at are algorithms. So in particular, we're looking at the time complexity and computational complexity of an algorithm. And so you'll be doing some self-exploration there and looking at one of the Arduino starters in Tinkercad and kind of determining, what kind of performance criteria the algorithm follows. So if you recall in Tinkercad, you can pull up your circuit and you'll be able to find all of the starters in this drop down here. So components, starters, Arduino. And in the first example, we're taking a look at this fade starter. So you'll be taking a look at the code, analyzing it. And another thing we're going to look at are data structures, just so like how you store data, right? If you're encoding something that's just true or false, you don't really want to use the precision of a floating point number, right? Like a 1.2 or 1.5. You just need a 0 or 1, so you might use an integer value. So we'll be looking at data structures. We're also going to be looking at flowcharts. So just like circuit diagrams are used to, logically or to show how a circuit should be connected, flowcharts are used to diagram the process of a software system. So we're going to look at that article, and we're also going to use this draw.io. So you can link this up to Google Drive or wherever you want to link it up, OneDrive as well. And you can make a drawing. And I like to turn the grid off here, but you can just drag and drop different shapes, right? So you have the start of your flow chart, and maybe you have a decision process here, or a decision block, and then a processing block. Oh, this is actually a start. So this is process. This is more like a terminator block, right? So start or stop. And this would be kind of like a decision. And, these are just generic names you would actually go and put in statements, kind of like here, and build up a flow chart. So we'll be using draw.io, and then we're going to jump to digital systems. So the first thing that we're looking at there are number systems. So we're familiar with the decimal number system, right, where we have a base of 10, but we're also going to look at binary and hexadecimal number systems and kind of look at their benefits and drawbacks. And then we're going to take a look at Boolean algebra. So Boolean algebra is used to figure out whether statements are logically equivalent. And this can be useful when we're designing systems that are meant to be fast, right? So you want to have the simplest logic possible usually. So we'll be taking a look at logic minimization, and logic gates and circuits. And so how we can use circuits to evaluate whether something is true or false, basically. It's a simple concept, but all of computers are built on top of these logic circuits and Boolean algebra. So then we're going to take a look at clocks, flip-flops, and counters. All right, so clocks are a way of timing something. Flip-flops are a way of storing data, and counters are a way of counting at a very high level. So you'll dig through some of these articles here. And then we're going to take a look at state machines briefly. So that should be pretty straightforward, right? So if you're in a state and something happens, you want to move to the next state or, stay in the same state. But it's an important concept for any kind of digital system to know the state of your system and how different inputs can impact that state. Uh, and the last thing that we're taking a look at is electronic measurement. So this week we're really going to get to play with some of the equipment in the lab, which will be nice. In particular, we're taking a look at multimeters. So multimeters are mostly used to measure voltage, current, and resistance. And we'll be taking a look at the user manual for one of the multimeters that are in the lab. So here's the user manual, and I think you'll have to install or download it somehow, but I've got it here. So these are pretty bulky manuals, and I've tried to make it somewhat easy to just control F the different sections that I'm asking us to look at again, just to make the navigation a little bit easier because it is a lot of information. And my goal is for us to just become a little familiar with navigating the documentation. So that's for the multimeter. We're going to play around with measurements in Tinkercad, and then we're going to actually measure them in the lab as part of a project, right? So this is just the exercise where we're looking at it in Tinkercad. And same thing with an oscilloscope. So oscilloscopes are used to plot these measurements over time, particularly voltage and current. So we look at how the current and voltage is changing over time, and we use these oscilloscopes to do that. So again, we're taking a look at user manuals and just getting a better sense of how these things work. So here's a picture of an oscilloscope. You can kind of see, this is probably a voltage waveform. These are the different points where you connect probes, and then there are a bunch of knobs. So this front panel can be a little bit intimidating at first, but once you become familiar with it, it's not too bad. And then this is a picture of a multimeter. So this one's a little bit easier, right? You press the button for what kind of measurement you want, and then you hook up your probes to somewhere here on this, front panel there, section 11. And then these are the two projects. So these projects closely follow some of the concepts that we learned about, or we will learn about in the exercises. So the 2-bit up counter and gate. So the basic idea is we have a counter, and the counter is turning on different LEDs. So then, when we have a 2-bit counter, so it goes 0, 0, 0, 1, 1, 0, 1, 1, and we encode the 0 as LED off. And then a 1 as LED on. So we just step through that sequence. And then while we step through that sequence, we also, so this is like a bit 1. Right, so it's a 2-bit up counter, bit 1, bit 2. And on the third LED, we're going to output the operation bit 1 and bit 2. Right, so this is LED 3. And so, once you get a better sense of how the AND gate works, you should see that the output of this AND gate should be 1, 0, 0, 0. So that's for the 2-bit up counter AND gate. And then the second part, it's a little bit more challenging. We're looking at a calibrated digital voltmeter. Um, but yeah, hopefully we can get through that. um, Let me stop this annotation here. So the last part is Simulink certification. And again, so that's going to be extra credit. So much like the previous week where we did the MATLAB on ramp, there's a Simulink on ramp, and Simulink allows us to analyze systems kind of more in a block diagram way. So if you look at example of Simulink, it allows us to model systems, using these drag and drop blocks, um, which you'll use a lot more in your career, most likely. If not Simulink, then something similar. Um, so I think that's all I wanted to talk about for the report. The quiz this week is just 3 questions. And again, there's the extra credit uh, place to submit your deliverable. And yeah, I guess that's all I had. Thanks for tuning in. See you guys.